Hi everyone and welcome to my channel. My name is Veronica and I hope IB students understand IB mathematics, applications and interpretation both at standard and higher levels. In today's video we are starting with a topic from the number and algebra strand and it's all about approximations and errors. This is one of the foundations for solving more advanced IB math problems, so let's make sure you understand it clearly. And let's get started. And in IB math, we deal with different ways of rounding numbers. You need to be familiar with nearest 10, nearest whole number, decimal places, significant figures. And rounding helps us simplify numbers, but it also introduces errors. That's why we also learn to calculate absolute error, so how much the volume might differ from the real one, and percentage error, how big the error is in relation to the actual value. And let's go through three practice problems: easy, medium, and challenging, so you can see how this works in action. So let's start with problem number one. And we have to round 387.46 to firstly the nearest 10. Okay, so the digit in the tens place is 8, and the next digit is 7, and 7 is greater than 5. So we have to round it up, and our answer is 390. Then we have to round our number to the nearest whole number. And rounding to the nearest whole number, we have to look at decimal, and decimal is 47. So 4 is less than 5, so we have to round it down. So we leave it as 387. And in point C, we have to round our number to one decimal place. And one decimal place, we have to look at the second decimal, which is 6. And 6 is greater than 5. And so we have to round it up. So our final answer is 387.5. And the last point, point D, says that we have to round our number to two significant figures. And our two significant figures are 3 and 8. And the next digit is 7. So we of course have to round it up. So our final answer is 390. So that's your basic review of rounding types, and now let's move on to a problem that includes error. Problem number 2 says that the speed of a car is measured as 83.257 kilometers per hour. And in point A, we have to round the speed to three significant figures. So three significant figures are 8, 3, and 2. And the next digit is 5. So we have to round it up, because when we have 5, we round our previous number up. So our final answer is 83.3 kilometers per hour. And in point B, we have to round the speed to one decimal place. So we have to look at 2 and 5. When we have 5, we have to round up our previous number, so 2. And our answer will be the same as in point A, 83.3 kilometers per hour. Then we have point C. What is the maximum possible error if the speed is given as 83.3 kilometers per hour, assuming correct rounding? So if it was rounded to one decimal place, our true value could be between 83.25 and 83.35. So the maximum error is 0.05 and always plus or minus, because between 83 and 83.25 and 83.35, the difference is 0.1, and maximum error is always the half of this, so the half of the difference between those numbers. And in point D, we have to express our answer from C as an absolute error and a percentage error. So absolute error, we already have it, so absolute error is this, so 0.05 kilometers per hour, and percentage error, we can quickly calculate it by dividing our absolute error by 83.3 and of course multiply it by 100, and in approximation it is 0.06%. And now let's try a more advanced example where rounding affects a geometric calculation. Problem number 3. A measurement is recorded as 4.28 times 10 to the power 3 meters. And it is also known that the value was rounded to 3 significant figures. Point A. We have to determine the smallest and largest possible actual values this measurement could be. So we can write our number in a standard form. So basically multiplying 4.28 times 1000. So it is 4280 meters. And now we can determine the smallest value. So then we can write it as minimum value, and it will be 4275, because when we have here 5, we have to round it up. So our final answer from this number, rounding it, we will have 4280, and in the same way we can find maximum value, which will be 4285, which is not included because it can be we can also write it as from closed bracket 4,275 to 4,285 in open bracket, because there can be also numbers such as 4,284.999, and we just write it like this. So this is our answer for point A. And in point B, we have to find absolute error and percentage error. And we already know that the absolute error is the half of the difference between maximum and minimum value. So the difference between maximum and minimum value is just 10, because it's 4,285 minus 4,275, it's 10, and absolute error is just 10 divided by 2, because it's a half of the difference between maximum and minimum value, so it's just 5, and we have to also remember that plus or minus 5. And now, of course, meters. And percentage error is just 5, so our absolute error divided by our 4,280, so our rounded answer. So we have to divide it, and of course times 100, and it is about 0.117%. And we have also point C. If this measurement represents the radius of a circular field, calculate the maximum possible area, giving your answer to an appropriate number of significant figures. So firstly, we have to recall the area of the circle, because we have circular field, and area of the circular field, you have this area in your booklet, and it is pi times radius squared. And we have also information that we have to calculate maximum possible area, and so we have basically take the maximum radius, and it will be pi times 4,285 and squared, because we have squared in here. This is our radius, so we have to square it, and it will be in approximation 5.77 times 10 to the power of 7 meters, and meters squared, because we have area in here, and this is because we have to give our answer to an appropriate number of significant figures, and in your final exams, appropriate number of significant figures is always 3. And in notation, we have these 3 significant numbers, so we have to round it like this. So as you can see, rounding affects not only simple values but also final results in real-world applications like geometry or physics. And this is everything, and thank you so much for watching. If it was helpful, don't forget to like the video, subscribe, and you can also leave a comment if you have any questions. And See you next time and good luck with your IB math journey!